Good afternoon, all. This is Satish Kumar, Assistant Professor of EC Department. Now, let us see the another video lecture series on FIR filter design using windowing techniques, Hamming and Blackman window. See, windowing techniques of FIR filters. The windows are the finite duration sequence used to modify the impulse response of the FIR filter in order to reduce the ripples in the pass band and stop band, and also achieve the desired transition from pass band to stop band. The FIR filter design starts with the desired frequency response HD of e power j omega. The desired impulse response HD of it is obtained by taking inverse Fourier transform of HD of e power j omega. The desired impulse response will be an infinite duration sequence. On multiplying finite duration window sequence with the infinite duration impulse response, which is used to design the FIR filter. Hamming window. The main lobe width is equal to 8 pi by n. The maximum side lobe magnitude is minus 41 dB. The side lobe magnitude remains constant with increasing omega. It can be defined as WH of n is equal to 0.54 plus 0.46 cos of 2 pi n divided by n minus 1 for n is equal to minus n minus 1 by 2 to plus n minus 1 by 2. Else 0.54 minus 0.46 cos of 2 pi n divided by n minus 1 for n is equal to 0 to n minus 1. This is the Hamming window sequence with respect to n is equal to 31. While we taking the amplitude response of the Hamming window, we can get the response like this. While we taking the magnitude response of Hamming window, we can get it as your 8 pi by n. While we taking log magnitude response of Hamming window, we can get it as your minus 41 dB with respect to normalized magnitude and normalized frequency. Next one, Blackman window. Features are the main lobe width is equal to 12 pi by n. The maximum side lobe magnitude is minus 58 dB. The side lobe magnitude decreases with increasing omega. It can be defined as WB of n is equal to 0.42 plus 0.5 cos of 2 pi n divided by n minus 1 plus 0.08 into cos of 4 pi n divided by n minus 1. For n is equal to minus n minus 1 by 2 to plus n minus 1 by 2. Else 0.42 minus 0.5 cos of 2 pi n by n minus 1 plus 0.08 into cos of 4 pi n divided by n minus 1 for n is equal to 0 to n minus 1, 0 for otherwise. This is the Blackman window sequence with the given the sequence where n is equal to 31. While we taking the amplitude response of the Blackman window, we can get the response like this. While we taking the magnitude response of Blackman window, we can get it as your normalized frequency as 12 pi by n. While we taking the log magnitude response of the Blackman window, we can get it as your minus 58 dB with respect to normalized magnitude and normalized frequency. Now we can see the frequency domain characteristics of all the window techniques. Rectangular window, the width of the main lobe is 4 pi by n. The first side lobe is minus 13 dB. For Hamming window, the width of the main lobe is 8 pi by n. Magnitude of first side lobe is minus 31 dB. For Hamming window, 8 pi by n. The magnitude of first side lobe is minus 41 dB. In Blackman window, the width of the main lobe is 12 pi by n. The magnitude of first side lobe is minus 58 dB. This is the ideal frequency response of filter design using windows. For low pass, we can substitute HD of e power j omega is equal to e power minus j omega alpha for minus omega c to plus omega c. Remaining all other limits are 0. In case of high pass, e power minus j omega alpha for minus pi to minus omega c to pi, remaining values are 0. In case of band pass, e power minus j omega alpha for minus omega c to 2 minus omega c1 to omega c2. In case of band pass, e power minus j omega alpha for minus pi to minus omega c2, minus omega c2 plus omega c1, and then omega c2 to pi. Now we can see the how the design procedure in terms of symmetric condition h of minus n is equal to h of n. First, you can find the desired frequency response hd of e power j omega is equal to c, and then cutoff frequency omega c for low pass and high pass, c1 and c2 for band pass and band stop. Next one is number of samples of impulse response will be n. Second one, you can find the desired impulse response by taking the inverse Fourier transform of hd of e power j omega. hd of n is equal to 1 by 2 pi integral over minus pi to plus pi hd of e power j omega into e power j omega n into d omega. Next one, choose the desired window sequence for n is equal to minus n minus 1 by 2 to plus n minus 1 by 2. H of n is equal to hd of n into w of n. And then find next step to take the Z transform of impulse response h of n to get the transfer function of the FIR filter. Here hn of z is equal to summation n is equal to minus n minus 1 by 2 to plus n minus 1 by 2 h of n into z bar minus n. Now we can convert the non-causal transfer function into causal transfer function. That's why we can take it as your z bar minus n by 2 as common. We can substitute h of 0 plus summation n is equal to 1 to n minus 1 by 2, h of n into z bar n plus z bar minus n. Finally, we can going to draw the suitable structure for realization of FIR filter. Now we can see the comparison of Canning and Blackman window. And the width of the main sine lobe window spectrum is 8 pi by n. In Blackman window, the width of the main lobe in window spectrum is 12 pi by n. The maximum sine lobe magnitude in window spectrum is minus 41 dB. The maximum sine lobe magnitude in window spectrum of Blackman window is minus 58 dB. The minimum stop band attenuation is 51 dB in Hamming window. And then the minimum stop band attenuation is 78 dB in Blackman window. Now we can see the assessment. The FIR filter design starts with the desired frequency response HD of e power j omega. The desired impulse response HD of n is obtained by taking inverse Fourier transform of HD of e power j omega. List the types of windowing techniques: rectangular window, Hanning window, Hamming window, Blackman window. How to calculate the desired impulse response HD of n, which is equal to 1 by 2 pi integral over minus pi to pi HD of e power j omega into e power j omega n into d omega. Compare Hamming and Blackman window. The width of the main lobe is 8 pi by n. In Blackman window, the width of the main lobe is 12 pi by n. Take is a transform of impulse response h of n to get the transfer function of the FIR filter. The transfer function h of z of the FIR filter is defined as hn of z is equal to summation n is equal to minus n minus 1 by 2 to plus n minus 1 by 2 h of n into z bar minus n. Thank you.